All right, we're going to be doing the Module 11 test review right now. First, we're going to find the center of dilation, and you just need a straight edge in order to do this. The way you do this is you connect both images point by point together, but make sure you go through the same letter. So I'm running A and A prime through the same straight line. I'm just going to do this with every single one of these. So we got B prime and B. And we're just looking to see where they meet up. And here's C prime and C. And if done correctly, they should all meet up at the same exact point, just like I did here. Okay. And then same thing over here. I'm going to run a line through D and D prime using a straight edge, E and E prime, and then F and F prime. You can see how they all converge at the same point. Right here and right here. So that is what we call the center of dilation. Okay. Next, we're going to be doing scale factors. So just recall, scale factor, we use K as the variable. Okay. And that's going to be equal to the new length over the old length. Okay. So we want to look and see here which one's the new, which one's the old, and be very clear. So just pick a horizontal vertical side that's very easy to identify. So this will be the old because it's D and E, and this will be the new right here because it's D prime to E prime. So the new will be the red, 1, 2, 3, 4, 5. Okay. And the old will be the green, which is 1, 2, 3. So that will be our scale factor here, 5/3. And remember, this value will be bigger than 1 when you're getting going from small shape to bigger shape, and it'll be less than 1 when we're going from big shape to small shape. So let's try another one here. And if you want to, you can pick multiple sides just to be extra careful. So we have here, we're going from JKLMN to JPQRS. So it looks like we have JKLMN, yes, is the big shape, and then the JPQRS is the small shape. So we're going to be getting a value that is less than 1 here. It's going to be smaller. So our new shape is going to be the small one. Let's use JS, which will be 1, 2, 3. And our original shape will be the big one, which would be 1, 2, 3, 4, 5. And sure enough, 3/5 is less than 1. Now on this last one, there is no vertical or horizontal side, so you have to use the distance formula to get the length of a diagonal. So you can pick any sides you want that are corresponding. Let's say DF, which corresponds to AB. Oh, sorry, DE. DF looks like would correspond to AC. There we go. So I'm going to find out lengths of those two and see what the ratio is there. So for DF, basically you're finding the rise and the run. And notice how each of these are counting by 2, right? So we're going to actually go to the left 2, and then up 2, 4, 6, 8, 10. So we're going to square both of those, add them together, and take the square root. That will give us the distance. So this is going to be square root of 4 plus the square root of 100. And then we'll have total of the square root of 104. So that's the length of df, right? A little bit over 10. And then do the same thing, but with AC. So we'll have over 2 squared, plus we're going to go up. Actually, we're going to go over 1. That looks like just over 1. Yeah. And we're going to go up 2, 4, 5. That's going to equal the square root of 26. And then we can find the k value, just like we did before, by taking the ratio of the new over the old. So the new is ABC, so that's going to be root 26. The old is going to be root 104. And if you just throw that into the calculator, it will come out to 1/2. Okay, next we're going to be doing the transformations and coming up with the values of each coordinate. So I always recommend when you see your image and pre-image are two different sizes that you always do the dilation first. We want to get these to be the same size first, and then if we need to do anything afterwards, we can move them around. So we have to do the dilation first. So we'll have x comma y, and we have to figure out basically what we just did. We have to do again and find out what that k value is, and we're going to use that for the coordinate rule. So we can take again one of the horizontal or vertical sides that we don't have to do distance formula on. Okay, so we're going A, B, C, D. So we're going from here to here. So it is getting smaller. So we expect our values here to be smaller than 1. So it looks like we're going from 1, 2, 3, 4 to 1, 2. So that would be a k value of 1/2. And we're going to have the same value for the x's and the y's. So that's our first transformation. So next thing is we want to take each of these coordinates and apply this transformation, meaning we're going to take half of each x and half of each y. So let's take half of 1, I get 1/2, 0.5. Half of 6 is 3. Half of 5 would be 2.5. Half of 6 would be 3 again. Half of 2 and 2 will be 1 and 1. Half of -2 and 2 will be -1 and 1. And let's go ahead and plot this and see what it looks like and see if we need to move anywhere else. So we're going to have 0.5, 3. I'll be right here, 0.5, 3. 2.5, 3. 1, 1. And -1, 1. So here we are. Okay, so next it looks like we don't need to rotate or anything. We just need to translate this down and to the right. So my next transformation is going to be to move it or slide it or just translate it down and to the right. So x and y, and we're going to plus, let's see, we're going to move it to the right. I know I'm going to add, that moves it to the right, and then to move it down, I'm going to subtract. I need to count exactly how much to move it. So let's first do the x's and pick some target points here. So I need to move this coordinate to here. So I need to move 1, 2 to the right. I'm going to have to add 2. And you want to check a couple of these, make sure it's the same for all of them. And then how far do we have to move it down? So we have to go down 1, 2, 3 to get these to be the same level. So down 3. So lastly, go ahead and apply this transformation to each of these. So I'm going to add 2 to each of the x's. So 0.5 plus 2 would be 2.5. 2.5 plus 2 would be 4.5. 1 plus 2 would be 3. And negative 1 plus 2 will be 1. And next, do the same thing for each of the y values and subtract 3 from it. So 3 minus 3 is 0. 3 minus 3 is 0 again. And then 1 minus 3 is negative 2. And then 1 minus 3 is negative 2 again. And you can verify that those are the actual coordinates of E, F, G, and H. We have 2.5, 0, 4.5, 0, 1, negative 2, and 3, negative 2. And that way you know you have the exact correct points here. Let's do one more, just with a quadrilateral trapezoid. So again, different shapes. So let's start by doing the dilation, figuring out the K value. Okay, so I need to find out how much bigger or smaller it's getting. And looking over here, we're going to go to TUWF. So it looks like we're getting smaller. TUWF is smaller of the two, so our K value should be small. So we got some horizontal and vertical here, so let's use that. For here we have, looks like 1, 2, 3 for PS. And TW is only 1. So it looks like the scale factor is just going to be 1 over 3 or 1/3. So we'll have 1/3 X and 1/3 Y. And all these values you can see are multiples of 3, which will make it easy. So multiplying by 1/3 is the same as dividing by 3. So just divide each of these numbers by 3. So 3, 3 will be 1, 1. 3 divided by 3 is 1. 6 divided by 3 is 2. 9 divided by 3 is 3. 6 divided by 3 is 2. And one more time, we have 2, 1. And let's just plot those and see what it looks like. So it looks like 1, 1, 1, 2, 3, 2, and 2, 1. So it's right here. So in this case, it looks like we need to reflect it over the y-axis for this to transform correctly. So my next step will be to reflection. Okay, over the y-axis. Okay, and the rule for this is going to be, okay, so we're going to map this right onto here. So we're going to go from 1, 2 to this point, which is negative 1, 2. So you notice how the y values stay the same. So my y value is going to map to the same number. So it stays the same. However, the x value, which is positive 1, is now negative 1. If you check with the other points here, positive 3 is now a negative 3 on this side. So we're going to go from a positive x to a negative x for a reflection over the y-axis. So we just took each of these and we just changed the x-coordinate to be the opposite. The y-coordinate stays the same. So all the x-coordinates are now the opposite sign, and the y-coordinates have stayed the same. And again, this last row should match these points exactly. So we have negative 1, 1, negative 1, 2, negative 3, 2, and negative 2, 1. So I know I indeed have the correct points for sure. Okay, let's flip it over. Okay, so here on the back side, we have triangles that are already similar. So we don't have to worry if they're similar or not. We just have to find the missing variable. So you want to find some corresponding sides to solve the problem. So let's first look at the triangles and see what is congruent or what is similar to what. So here we'll have triangle ABCD. EB is going to be similar to ADC. ADC. Okay. And then we just have to find out, do a short side of each side, triangle here. So we have AE over AD. We're going to do that first. And that's going to be proportional to the other sides we have numbers for. So it looks like EB over DC. And you'll notice that I use the small triangle for the top and the big triangle for the bottom. That's very important. Now we can just fill in the values and solve it. So AE right here is 5.6. Now AD, from A to D, we know right here ED is Y, and this part AE is 5.6. So I'm going to add those together to get AD. I'm going to have Y plus 5.6. And now be proportional to, small triangle, we'll have 4 over 5. Then we just need to solve this by cross multiplying. So we'll do 5 times 5.6 and now equal 4 times y times 5.6. So just distribute and solve here. So 5 times 5.6 will equal 22 point, see here. Oh, will equal 28. Yeah, there we go. Equals 28, and this will equal 4y, and 4 times 5.6 will be 22.4, just by distributing. Then we can subtract 22.4 from 28, and we'll get 5.6, and then divide that by 4, and that will equal 1.4. There we go. So this value right here equals 1.4, and looking at the picture, that does seem reasonable. Okay, next, number 9. I have a little bit more here. So these are not in the same orientation, so just be very careful what's congruent to what. So use these markers to help you out. So you know from the single marked angle to the double marked angle is going to be proportional to right here, the single to the double. Right? And then we have from single marked to the 40-degree angle, and here, those will be proportional. So very important that we establish that from the beginning. So we'll have 12 over x plus 1 will be equal to 6 over x minus 3. And then just like we did on the last problem, let's cross multiply. So 6 times x plus 1 will be equal to 12 times x minus 3. So 6x plus 6 equals 12x minus 36. And looks like I'm going to add 36 to both sides. So I'm going to get 6 plus 36, which is 42. And subtract 6 on both sides. So 12 minus 6 gives me 6. And then divide both sides by 6 to give me 7. There we go. So if we plug this in here, 7 plus 1 would be 8. 7 minus 3 would be 4. And that should put us in proportion. Okay, one more. So again, let's just be very careful what we're saying goes together. So up 8 over x minus 1. That should be in proportion to 10 over x plus 2. and cross multiply and solve like we did on the last one. So we'll have, it's going to distribute from here, 8x plus 16, 10 times x, 10x. 10 times -1 is -10. Go ahead and solve this. I'm going to subtract 8x to both sides. So 10x minus 8x is 2x. I'm going to add 10 to both sides. So 16 plus 10 will be 26. Divide both sides by 2. So I have x equals 13. Okay. So that would make this side equal to 15. 13 plus 2, and 13 minus 1 would be 12. All right, let's move on. Next, we're going to have to determine if they're actually similar or not by using our different theorems. And if they are, we're going to write a similarity statement. So a reminder that we have 3 theorems that we're using: angle, 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 side, angle, and side, side, side. So we're looking for congruencies of this type. So over here, we have a side, an angle, and a side for each of these. Now, at first, that looks like that means we're using side, angle, side. However, notice how the angle must be between the 2 sides. So for side, angle, side to work, here are my 2 sides. We'd have to have angle C be congruent to angle H, which we do not. Okay, we do not have that. So for this one, it's actually not similar. Okay, and if it's not similar, we cannot write the statement. Okay. Next, on number 12, make this a little bigger. Here we have a reflexive angle. R is shared by both of these triangles. And then we also have this congruent as well. So we have 2 angles that are congruent. So we can use angle, angle here and say, yes, they are similar. So we can say triangle, let's say RSV. RSV will be similar to, and then for the big triangle, R is congruent to R, S is congruent to T, and then angle V is congruent to angle U. Okay, and this is by the angle, angle theorem. Okay. Number 13, we have, looks like side, side, side. Let's check the portions, make sure they're actually the same though. So basically, does 9 over 16, or 16 over 9, is that proportional to 5 over 3? And looking at this, we can tell that 16 over 9 does not reduce to 5 over 3. If you want to check the decimals, you can. So another one that looks like from the beginning it might be similar, but once we check the proportions, it does not work. So we're going to say not similar, therefore not similar. All right, going down here, we got one angle that's already congruent, so that's good. And then here we have some vertical angles. Angle C is congruent to angle C, so these will be similar by angle, angle theorem. As soon as we get 2 angles congruent, all 3 angles must be congruent. So we know angle B and angle D are also congruent. All right, so we can write this out. Let's say here, angle ABC, triangle ABC will be similar to, and now A is congruent to E, so I got to put E first. B is congruent to D, and then C is congruent to C. There we go. Next, number 15. Again, we have 3 sides, so it looks like a candidate for side, side, side theorem. Okay, maybe. We got to see if the proportions are the same. So we got to check to see if 4 over 6 is that the same as the other sides? So we can do 8 over 12. And then also 10 over 15. And if you go through each one of these and double check, looks like they all reduce to, divide top and bottom by 2, I get 2 over 3. Top and bottom by 4, I'll get 2 over 3. If I divide top and bottom by 5, I'll get 2 over 3. So all these reduce to the same scale factor. So yes, it is similar. So we can say, let's see here, triangle GHJ is similar to GHJ. I go, G would be the green and the red. That over here, green and red is L. So that's going to be L. H is where the blue and the red are. So that's going to be M over here. And then the last letter must be N. There we go. Okay, lastly, oh no, 2 more. We're going to see they're similar down here, and just do some true and false on them. See which ones are true, which ones are false. So angle C is congruent to 50. So is this 50 or not? Well, if they're similar, yes, they are. Okay, we got these are 60. Right? So these must be the same. This must be 70 as well. Okay, so we're going to say true here. AC, does that equal 4? So we're asking, does AC equal 4? And we would say no, because you can see if they're in proportion, these would have to be the same for these to be the same. So we're going to say false for this one. And AB congruent to DE. Okay, AB congruent to DE. And again, no, if these fall in the same proportion, these cannot be congruent either. So say false. And then is angle D congruent to angle E? And those are corresponding angles, so we'd have to say true. All right, lastly, we're going to do a review from our last chapter and just to see if this is a parallelogram, rhombus, or rectangle, or neither. Let's go ahead and plot this carefully first. -4, 1, right here. Oops, sorry, -4, -1, that's down here. That's Q. We have -2, -5, that's down here. It's R. We'll have 4, 2, 4, -2 right here, which is S. And we'll have 2, 2, which would be T. Okay. At first glance, it does look like it's a parallelogram. We just got to check a few things to make sure. So first, for a parallelogram, we know that opposite sides are parallel. Okay? In other words, they have the same slope. So I have to check to see if these opposite sides have the same slope. Okay? So I can go, let's see here, over, so rise over run. So we're going to go down 1, 2, 3, 4, down 4, over 2, and here we have down 4 over 2. So we got one pair, but you do have to check both. So for here, we're going to have up 1, 2, 3 over 1, 2, 3, 4, 5, 6. And then check here, we have up 3 over 6. So yes, it does look like it's a parallel because both sides, or both pairs of opposite sides have the same slope. And just to write that out, we can have QT is parallel to RS, and my blue sides were QR is parallel to TS. Okay, so we know it's a parallelogram, so we can test to see if it's a rectangle, rhombus, or neither. So for the rectangle, we are going to see if angles are 90 degrees or right. Okay, and we're going to do that by seeing if they're perpendicular. So the slopes should multiply and equal -1 if they are indeed perpendicular. And so the slopes here use the same numbers. Basically, we have -4/2 times the red slope here, which is 3/6. And if these multiply and equal -1, then they are 90-degree angles. So if we multiply these really fast, -4/2 is -2, 3/6 is 1/2. So -2 times 1/2 is -1. So yes, it is a rectangle. Okay. Next, we're going to see if it's a rhombus. So for the rhombus, what we do is we check the diagonals to see if those are perpendicular. So I'm actually going to see if RT and QS are perpendicular. So find the slopes of each one of those and see if it passes the same test as the rectangle. Okay, so we're going to go up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4 for that diagonal. And for this one, we're going to go down 1. To the right, 1, 2, 3, 4, 5, 6, 7, 8. So clearly, 7/4 times -1/8 does not equal -1 because nothing's going to be canceling out here. So no, it's not a rhombus. This is a parallelogram that is a rectangle. All right, so my advice for your reviewing tonight is to make sure you can do this whole review by yourself with no help and be able to explain all these theorems and show all the work for these problems to be ready for your quiz tomorrow. Okay, good luck.